And we're live right now, at least recording live. So tonight we're going to start with a presentation with Chet. Then we'll move into our meeting tonight, our formal meeting, and then during our formal meeting on old business, I guess. I don't know what I want to do, Mike. You want to table the field day discussion, even though it's old business because we opened it up already. We'll call that new business then, and just and go there with the field day discussion.
Yeah.
Okay. So before I get started, is there anything we need to get off the table before I hand it over to Chet? Chet, by the way, what is your presentation on this evening?
I have two projects for CW that are based on the Arduino board.
Awesome, because that's what I've been dabbling there myself right now.
Well, the first one somebody might actually want to borrow from me. The second one is a project that I came up with, something that I invented myself. Actually, it was a reinvention of something that other people had already invented, I think. But Ken helped me, Ken Pierce, NU3A, helped me test it out. And we verified that it does work. But anyway, I need to share my screen somehow, Alan.
I'm sharing the screen, so without any further ado, I'm going to hand it off to you and you on the screen.
Okay.
All right.
How about that?
There you go. Good.
We need to
I'm going to go and
slideshow
you here.
Slideshow from the beginning. So it's two Arduino projects for CW. The first one is called CW-Elmer. The second one is remote CW keying. I'll talk about both of them. First is the CW-Elmer. This was an article in the January QST. I don't know where you buy this device. There's the picture of the commercial device, but it was so simple to build. I built one. It was very easy to assemble. It's a code practice oscillator, but it does far more than that. If it was just a code practice oscillator, it wouldn't really be worth a whole lot. It's hardly worth devoting an Arduino to, but it does send code practice at 5, 10, 15, 20, 25, and 30 words a minute. So if you want to practice your copying, it's useful for that. The thing that I thought was the neatest part of it was that it actually analyzes sent code. And what I mean by that is if, let's say you're trying to send your code at 15 words a minute, you can send it into the machine. I'll do this on a demo later on. And it will then tell you, let's say I've chosen 15 words a minute. It'll tell you how long the dits should be, and it'll tell you how long your dits were, and it'll tell you how long the dashes, the DAWs should be, and it'll tell you how long your DAWs were. It turns out the last time I tested this at 15 words a minute, my dits are pretty close, but my DAWs are way too long. But anyway, I think is a very useful function, particularly if, for example, you're trying to set up a bug and you want to make sure that the dits and the DAWs are at the right speed. It also has exercises. You can practice your dit length and your DAW length. I didn't find those to be particularly useful, but they are part of the program. It uses the Paris Morse code system. This is pretty interesting. I don't know that I'd seen this before, but I had seen this formula. A dit in milliseconds is 1200 divided by the words per minute. So at 20 words per minute, a dit is 60 milliseconds long. The DAW, of course, is 3 times the dit length. Inner character is 1 dit length. In other words, the spacing between the dits and the DAWs. And the spacing between characters is 1 DAW length, and a word spacing is 7 dits. So if you send Paris, P-A-R-I-S, and a space, that takes exactly 50 dit lengths. And so the number of times you can send Paris in 1 minute is equal to the words per minute. It's kind of a useful piece of trivia. Anyway, here's the circuit. I can't believe how simple it is. Of course, all the brains are in the Arduino, but you connect up a speaker, you connect up your key, you connect up an LCD display, and put power to it, and it works. Of course, you have to program the Arduino itself. You have to put the sketch into the Arduino, but that's available. Here's the part list. Not many parts. I didn't put a box on there, but I bought a box from DigiKey, and I used a breadboard for holding the Arduino itself, and then everything was just point-to-point wiring, which of course is not very critical. The sketch itself is available on arl.org QST in depth. If you've never programmed an Arduino before, you're going to need the IDE program, and this is where that's available. But once you have this and you've done it, got a little experience with it, it actually is very easy to move the sketch from the memory into the Arduino. Here's what mine looks like. You saw the picture of the commercial version. I put my external key on it. Of course, here's the display on-off switch. You can plug any key or keyer or whatever into it to make it operate. What it has is a series of options, I guess is the way to say it. It rolls through the options, and when you hit the key, it'll stop. So, for example, on this particular picture, I've stopped it at sending, and I'm going to do that for the demo. So you'll hear my sending anyway, and then I'll analyze it, and I'll tell you what the analysis said of the timing on my sending. Here's the inside of the box. There's the breadboard and the Arduino plugged into it, and the two capacitors, the LCD display, the batteries, the switch, and the terminals. This, by the way, is the speaker on the inside of the box. I have mounted an external speaker temporarily just to get a little bit more sound so that maybe you can hear it a little better on the Zoom meeting. So I'm going to give a demonstration. I'm going to turn this thing on. The first thing it does, it sends. Can you hear that? Okay.
Yes. Yeah.
Yeah, you got some interference coming through.
Interference. That's called code. Oh. The background noise is raining to beat the band here right now. Anyway, so it's going through the different options. I'm going to stop it at sending. All right. So and it's telling me that I can hold the key down for 2 seconds to exit, but anything I send, it will display on the LCD display. So that was it. It put the dots and the dashes and said C and Q. So I'm going to do that a couple of times and send my call sign, and then we'll analyze the lengths of the dits and the das. All right, so now I can hold the key down for 2 seconds, and it goes back into rotating through the options. And I'm going to stop it at analyze, and it's at 15 words a minute, so it's saying the dit length should be 80 milliseconds. I had 16 dits, and my average was 82, not bad. The target was 80. The shortest was 69 and the longest was 105. I don't know why I'm so inconsistent. The DAWs are supposed to be 240 milliseconds. I had 16 DAWs. My average DAW length was 304. That's what I was saying. It should be 240. It was 304. That's what I was saying. My DAWs are too long at this speed. I prefer it. It says my measured rate was 13 words a minute. All right. So that's just an example of what the thing does. That's an example of code practice oscillator and analyzing. So it's useful for sending and receiving practice. It's useful for adjusting a bug if you really want to set your bug up correctly. For anybody who operates CW, it gives you the quantitative analysis of the DITs and the DAWs. And I'm willing to loan this thing to somebody if they would like to borrow it. Speak up. The one thing that I didn't understand, and some of you technical experts may be able to explain this to me, is what's the difference between memory and an EEPROM? The Arduino, this is an Arduino Micro, by the way. It's not an Arduino Uno. It's smaller than the Arduino Uno. And it has an EEPROM in it.
Okay, so
And
your EEPROM is like permanent memory, but
yeah,
you really shouldn't try to write to it too much because it doesn't have as many writes as.
And I understand that,
yeah.
Except the program memory, which is not EEPROM, it remembers that too.
Yes, that's an SD.
So the other thing is that regular memory is very fast. And when you write to EEPROM, it's very slow. And when you read from EEPROM, it's very slow. But when you stuck with RAM, it goes literally, but it's amazingly fast. It's unbelievable.
Well, I think that helps me understand this a little bit. I don't know why they put the EEPROM in there because the other memory is fast and it stays in there too.
But Ken's right. If you power it off and back on again, the EEPROM stays and the memory doesn't.
So you actually have three types. You have three kinds of memory in that device. You have the EEPROM. You have SD, flash memory, and you have RAM in there. So the flash is what's persistent. The EEPROM, the only thing I've ever used that for is like storing keys.
That's probably something like that is what they're doing in this program. I don't know.
Yep.
But so the flash memory is what stays even though the power is turned off?
Mm-hmm.
Yes,
Yep.
but the next time you upload a program to it, the flash memory is erased and a new thing is put on there. The EEPROM will stay no matter what until you write to that.
Yeah, okay. Well, no matter what, you don't have to leave the power on and it still remembers the program.
I've used it for my Wi-Fi usernames and passwords and things like that.
Yeah.
On devices with Wi-Fi.
Well, for whatever reason, the developer decided to use the Arduino Micro, and he actually utilizes the EEPROM for some things that probably get set up initially at the very beginning, and then from that point on,
yep,
it doesn't need to re-access the EEPROM.
Right. Yeah. So Ken's 100% on the mark with his description of the three areas of memory.
Yeah.
So, but the EEPROM is seriously much slower than the regular RAM.
Yeah. Okay. That's that. I haven't heard any volunteers to use this, but anybody would like to use it certainly can. I don't need the practice myself.
Are you sure? Are you sure, Chet? Really?
I operate CW every day, Foster.
I was just poking at you. I'm just sorry. Sarcasm goes well. It's like, sorry.
Okay. Remote keying without latency. If you're operating a ham radio over the internet, there's a delay between when you do something on your computer and when it ends up over at the radio. And if you're doing your keying from the computer, turning the key on and off here, there's going to be a delay as the ons and offs reach the radio. And that in and of itself is not a problem if the delay was constant, but it's not. So in my experience, and my Flex radio actually measures the latency. It varies between 150 and 100 milliseconds. Well, at 30 words a minute, a DIT is 40 milliseconds long. So if it's varying, it's definitely going to change the length of my DITs and DAWs, of course, but it's going to be most noticeable, highest percentage change in the DITs. That's dithering that becomes more pronounced at speeds higher than 25 words a minute. One solution is to use a keyboard, which is what I do most of the time. And the characters are sent using ASCII high speed over the internet. They get received by the radio, and the radio makes the DITs and the DAWs, and that you send perfect code that way. So there's no latency effect using the keyboard. It's only when I'm doing keying at my computer, like I did straight key night. I actually have the capability of doing this, but I'm sending it like 15 words a minute with my straight key, so the dithering is not particularly a problem. But if you go to higher speeds, it becomes more of an issue. So I had an idea, which apparently other people had tried and showed that it does work. Do standard keying using a straight key bug or keyer, but decode the CW, convert it to ASCII, send the ASCII over the internet. Well, first of all, send the ASCII to the PC. The PC sends it over the internet to the computer at the other end, or the radio at the other end, to make the DITs and the DAWs. And that's a two-part problem. The first part is you have to decode the CW, but there's an Arduino that does that. So that was a good start. And then you have to convince the PC to take ASCII characters from the Arduino and put them into the keyboard character queue. And I found a program to do that. So I'll show you how that's done. The Arduino, there's an Arduino Uno decoder by Bud Churchward, WB7FHC, and it does a great job of decoding, but it only operates up to about 30 or 35 words a minute, and it displays the code that it hears on an LCD display. Well, my application, I don't need the LCD display, and there's a lot in his circuit that I really didn't need. That additional circuitry will convert the audio that comes in from the speaker into digital input for the Arduino. Here's what the circuit looks like. Here's the Arduino chip, and here's the LCD display and the chips used to take the audio and turn them into ones and zeros. So basically, if you cut this drawing in half, everything on the right side I don't need. I just need this guy right here. So I took his sketch and I rewrote it. I took all the sections that had to do with LCD out, and I eliminated all the electronic parts that convert the audio into different ones and zeros. The reason that I did that, it speeded it up. I can now get it to receive code at 55 words a minute, or 50, somewhere between 50 and 55 words a minute. So it's not speed limited for all you really, really fast CW operators, which I'm not. But I did want to increase the speed. The decoded characters then were directed into a COM port on the computer. Here's what the circuit looks like. It's very, very simple. The USB line comes from the computer into the Arduino Uno. There's one connection to one signal pin on the Arduino. I added a couple of components here, the resistor and the LED. So the LED lights when I hit the key. It's just a convenience. It's not really necessary, but the Arduino picks it up, converts it into a character, and then sends the character at 9600 baud into the computer. So it goes out very, very fast. So it will go over the internet very, very fast. I assume that's in the range of 9600 baud or faster, maybe, I don't know, whatever it is over the internet. Here's what the deal looks like. There's the Arduino. It's in a plastic box that I got on Amazon. Here's the LED and the resistors hidden away in there. This is the key line, and this is the line to the computer. The second part of this is a program called Datasnip. It's a program written by some folks in Australia, and it will take the data from a COM port and place the characters in a keyboard queue. It doesn't matter what you're typing into. I mean, it's in this particular application, we're talking about typing into the keyboard input for a remote radio control program, but it can be any program that takes keyboard input. So if, for example, you wanted to write a letter, you put it into a word processor program, which is what I'm going to use for the demonstration, is a word processor program. Here's the Datasnip control panel, and turns out my Arduino is plugged into COM port 3, and I can turn that on, and I'll show you how it translates what I'm sending into characters that go into the keyboard queue. The device plus the modified program plus Datasnip converts sent code into keystrokes, which is that's all it was intended to do. With the proper setup of the remote station, code can be keyed in, and perfect CW without latency is sent up to over 50 words a minute. My program is written specifically for flex radio. So if you type what is that, an open parentheses, you get KN sent at the other end. A plus sign is AR, an equal sign is BT, and a dollar sign is SK. But other sets of pro signs can be written into the sketch depending on what your radio is controlled by. And this just happens to be the flex options, and it'll operate up to 50 words a minute. So I'm going to demonstrate this, but instead of sharing this guy, I'm going to share on here. Okay. First of all, I have to turn on this with redirection. And I haven't lost you. Hold on.
We're still here. We're just admiring Sam and his antlers coming out of his head there.
Yeah.
Well, I lost my Zoom.
We still see you.
Yeah, I know.
And actually, you lost me when you started talking about CW.
I know, I was gonna lose everybody.
Those are fighting words.
Click on share screen.
Yeah.
It's just to go, when he goes CW, you have to go C for chat and then W for WA3I. It's easy after that.
No, he's got the sharing privileges, so he's good.
There, that's what I wanted to get to. Whew. All right, so here we go, the Word document. All right. Can you see, are you seeing my?
Hey, Chet, all this just for Word?
Yeah, well, it's going into Word right now.
I know, I'm kidding with you.
But I don't know if you can hear that.
Yep, we can hear it.
You can hear it?
Yep.
Yeah.
That's how it works.
That's pretty cool.
One of the interesting parts of all this, I'll stop sharing now. You can see that I can send code with my keyer and it appears in the Word program.
I could see Chet. I could see us take Dave Scott's net controller, his what do you call his cheat sheet that you read from when you talk about when you open up the net, the big long opening, and throw it out through, and we're just going to hear a bunch of dits and dots, and we're all going to have to figure out what you're trying to say.
You'll need the decoder
That's a long
to figure it out.
preamble to do that.
That's a lot of dits and dots. Yes.
Well, I'm on a blog group for Flex remote keying, and latency is a major issue for a lot of these guys. And so they were interested. I don't know how many people actually tried it, but it actually does work, and it works flawlessly as long as you send good code into the decoder. If you send crap into the decoder, it comes out,
Why don't
garbage in,
they? I'm
garbage
just
out.
curious. I know it's we'll call it the KISS syndrome here. You keep it simple, right, as best you can, right? But the only way you could overcome something like that is if you have the ability to embed in that ASCII transfer times offsets, where you have the ability to at least, have a calibration benchmark, and then you have a time offset, and then you can put everything in order. You know what I'm saying? That's probably
Yeah, in fact, protocols like RTSP, RTP already have all that stuff built in, so you could just use one of them. The other thing I would say, well, oh, by the way, the technical term you're looking for is jitter. When you talk about changes in network timing, that's timing jitter.
Jitter, okay.
Yeah, and so this is really pretty cool. For your next version, something you might want to experiment with is you can have the Arduino generate the keyboard input directly, because
Is that right?
yeah, because there are Arduino libraries that will emulate a HID, a human interface device. And so you can basically just call functions. You plug the USB right into the PC, and then you can call functions in your sketch that will generate keyboard characters.
I have a nano keyer that does that.
It's not every Arduino that can perform that human interface device, but if you look for like Pro Micro or Arduino Duo.
Well, isn't it anything that has a USB port?
Not all of them will work as an HID, because some of them only work in one direction.
Does it have to be? Why not just use a standard keyboard like I do with my nano keyer? I just plug in a regular key, not a USB keyboard, the old PS2 keyboard into.
You can also do that. That would be a different approach, but you could do that the same way you're generating the RS-232, is you just generate the keyboard codes. But if you have a modern PC that doesn't have one of those, then your best bet is to emulate a HID.
Mhm.
Right. And Ken's right. The Duo is your best bet for that, because I have a small keyboard that I use for the Kerbal Space Program game, where I can launch stuff and move around in space and not have to remember which shift keys and stuff on that. So.
And I built a keyboard out of an easy button, and
yes.
When you hit the easy button, it says that was easy, and it types out my password for my computer in Ham Shack.
Very good.
Nice.
That's neat.
Just don't want to connect that and send it, out over CW. Then everybody will know.
That was easy.
That's clever. I like that.
Well,
that
that's
it,
it,
Chet? What else
ladies
you
and
got?
gentlemen.
Is that it, sir?
That's it.
Any questions for
Pretty
Chet?
cool.
Well, thanks for all the comments. And it's not, it's jitter, not dither.
Yeah, those are, they're two separate concepts, but typically in when you're talking about network protocols and you're talking about things arriving not in the same time that you send them, that's called timing jitter.
Jitter. Okay.
Well, thank you, Chet. Thank you for your presentation.
That was awesome.
Thanks, Chet.
I'm glad you enjoyed it.
Good job. Makes me want to learn Morse code now.
Oh, you better be careful with your stuff.
Wendy, you want to borrow this? You want to borrow my Elmer?
I'm not ready for it. Let me pass my general next, okay?
Okay.
That's next week.
Guys, with all the comments about CW, we've got an opportunity coming up this weekend to test things out. I'll be operating pretty much exclusively CW, and I see that we can now do FT8, FT4. There's a good challenge. We've got the gauntlet down now.
Well, then you really, there goes CW.
Yeah.
Well, we shall see.
Yeah. And let the debate begin, right?
What I find particularly depressing is I wrote, almost 40 years ago, I wrote Z80 assembly language code to essentially do what Chet is doing. I needed it for storage. I had an 8-inch floppy drive, and the whole thing was powered with a 10-pound power supply.
Oh, it's
so I'm depressed.
I know. Yeah, I remember writing software in my old Atari 800. It's the same. It's amazing how it's equal to an Arduino right now.
TI 99A.
I think the biggest thing I got out of this was Chet was able to make his keyer program work with an Arduino and basically 5 wires to it, because I know all the Arduino stuff I do looks like a bird's nest with all the crap hanging off of it. He's got 4 wires, a display. Those serial displays are just awesome. If you haven't used one of them before, buy one and do that.
Chet's approach was the minimalist approach.
Yep.
And sometimes that's all it takes, right, to get it done.
Yeah.
So, all right, so we get started with our meeting tonight.
I'd like to make a motion to congratulate Alan for embracing the new meeting format of presentations first and meetings second.
Do I get a trophy for that?
No, but I need a
Second that
second that motion.
We haven't started the meeting yet, so.
Yeah.
Oh. Well, logistically, I can't make a motion, but I thought I would bring that up. I think this new format.
You're allowed to make the motion outside of the meeting, meaning that you.
I can make motions, but seriously, dude, I think I like this new format a lot. I think having the presentation first and then the meeting second is just awesome.
Yeah.
Yeah, no, it definitely, for me, I've not been doing this very, very long, like some of you, but yeah, I was getting used to the idea of waiting to the end and, the excitement at the end of getting a presentation, and now we get it up front, now you got to deal with me for the next 40 minutes. How you like that?
So the best part is that Dave can motorcycle into the meeting late and still be here for the treasury report.
Yeah,
So
yeah.
I'm just like, it's a win-win everywhere.
I don't think Dave.
So how do I motorcycle on Zoom? That's
All right, let's get rocking here because we got a lot of discussion points here on field day. So I want at least let's cycle through this first part of this meeting. So I guess we'll start out with a treasurer's report. Unless
I
we
guess-
have,
Pause.
yes.
Can you stop
Yeah.
the recording and then
Oh, yeah.
start,
Yeah,
and
I
then
will.
just wait to start another one? Because then we have the presentation separate.
You got it. So I'm gonna stop it. Yeah.